Hey guys, Easy Science here. If you're studying for an exam or just learning for fun, you've come to the right place. Today's topic, part 1 of our legendary playlist of calculus. The legendary mathematical concept of calculus I'll explain to you. Only the basics for now. Calculus is the study of continuous change, like geometry is the study of shape of objects and geometric properties, and like algebra, a study of arithmetic operations. For example, you see this line right here, right? That would be a normal graph of, oops, here, y is equal to something. Well, usually it's only linear, like x. If we make this, it's 1, 1. One move in the x direction and one move in the y direction, and it only changed by 1. It's a straight line, and you can find this also by a slope formula. Slope, sorry for my writing, is equal to y2 What does that mean? Basically, y2, or y to subscript 2, is your endpoint. Here is 1 to the left. 1 second. I'll move this graph back to where it was. I'll label it 1, 2, 3, 4, 5. Actually, okay, here a better graph. Sorry for the unexpected waste of time. So if we have a graph, something like this, which would be y is equal to x. So how would we calculate the slope? So follow this formula, like I said, y2 minus y1 divided by x2 minus x1, you'll get it. So let's say we move 2 steps to the right in the x direction and 2 steps up. So that would be our endpoint with coordinates 2, 2. Let's plug those into the numeric values. So it would be 2 divided by 2 minus x1 minus y1. So where did we start from? We started from here, from 0, because that's where we took our steps from. It's like you're going from your house to the grocery store. You don't just start from a random place, you start from your house. So but this is basically your origin in most graphs. You could also start from different places, but we'll get that. We'll go to that in the future videos. Those are harder concepts. So that would be 0. So then it would be 0, 0. So let's label these y2, x2, or x2, x1, y2. Like you know, x coordinates are in the left, y coordinates are in the right. X coordinates are in the left, y coordinates are in the right. So if we fill this in, it would be minus, like following that, plugging them in. So 2 minus 0 is 2. So it would be 2 divided by 2. Same thing as 1 divided by 1 is equal to 1. The slope is 1. So what does that mean? That means the rate of change is 1, or 1 divided 1 for every 1 step. So for every step in the x direction, you'll go 1 step in the y direction. Okay? Makes sense. That's pretty easy. But what if it was a curve? Okay, things will get complicated. So what if we had the graph y equals x squared? As you can see, it's curved, not a straight line. So you're thinking, okay, we could do the same thing. No, because it's not a straight line. If you do it from this point, you go to the origin, or let's say you went from the origin 0 to 10, and it looks like you went how many? Or let's go to 9 to make it a bit easier, because it's you could square that. So 3 to the right, okay, and you went 9 up. Oh, okay. That we could put that in. So it'll be 9 minus 0 divided by 3 minus 0. Okay, so the rate of change would be 3 by 1. No, because if you drew a straight line to there, it would be much bigger than that. So it won't work, because the straight line would have a bigger slope than the thing you found. It can't be used like that. What calculus does is brings concepts of derivatives. I'll explain those in future videos, but here I'll break it up. Calculus is divided into two categories: differential calculus, which is the rate of change, like I told you, and integral calculus, accumulation. That's a harder concept, which we'll talk about in very future videos, which connects the fundamental theorem of calculus, connects differential and integral calculus. So, let's start with a bit of, there's also a concept of a limit. This is just an introductory video, so I'll just give you a head start of what calculus might look like. Okay, so when you're trying to find a rate of change of this graph, you, instead of looking just at the line or making a line and finding if that won't give you precise results. You have to magnify into a certain point. Look in there. If you magnify enough, it'll be a straight line. That's basically what a limit is. You might have seen this. I'll explain that in the video after this. This is an example. So, that is one of the steps in differential calculus, in finding the slope of curved lines. Another type of geometric problem, or a geometric problem that calculus enables you to find, or to solve, is, okay, let's try solving this. So 1, 2, 1, 2, 3, 4. Find the area. Well, you probably can't read my letters, but it'll be 2 multiplied by 4, should be 8. 8 units squared, because we don't know exactly what that is. So, how do you find the area of this? It's basically the same concept, but using rectangles. That's what integral calculus is for. So instead of having just, how would you do this? First, you would start making, like, put one rectangle here, another rectangle a bit up, then one right there, one right there, one right there, one right there, and keep going on. But you see there's little spaces in between there. Well, like with the zooming in part, if you zoom in far enough, well, not zooming in, but instead of having 10 rectangles fit in there, you could make it 50. With 50, the intervals will be super small, and the changes won't even be dramatic. So you could easily find the area like that. That's where you might use the sum function, sigma. This is the sigma, which basically finds the sum of a lot of things in the integral, the main thing in integral calculus. Calculus can also be applied in real-world concepts. For example, like with the area problem, let's say you have a house. My best impersonation of a house. Find the area of the rooftop. Okay, that seems pretty simple. You just calculate the area of this rectangle, and this one, and that one, and the other one. Or you could just find the area of a rectangular prism. But calculus takes it to the next step. Let's say you need to calculate the area of the top of a sports dome. You probably have no idea how to do this. It's curved. You're probably thinking maybe the area of a circle would work. Well, not necessarily, because it's more of a curved circle, Remember, we're talking about curved graphs and calculating areas of curved graphs inside. Yeah, you're basically going to use the derivative calculus, differential calculus, and integral calculus to solve these kind of problems. This is where engineers are really used for. So if you like this type of math, you might want to become an engineer. Very good paying job. So, to sum it up, what did we learn today? We learned that calculus is a measure of continuous change. For example, curved functions, curved areas, and other things. You could also combine the rate of changes to find other problems that have real applications to the world. So important things to note are the names of the types of calculus, integral and differential. If you didn't know what the slope was, we learned what the slope was in more or less simplified form. We learned what areas of curves are, and we also learned curves, just the basics of how to find the slopes of curves. And we had a sneak peek of what the limit is. Remember, zooming in? Yeah, that's what the limit is, basically. So, this is what you should remember. This isn't what you're probably going to need for your exam. Well, it could be for a review or whatever, but this is just a starting, or like a teaser, for what's going to come up in my calculus playlist. Stay tuned for next video about limits. Limits, one of the most important concepts, which builds on the other concepts. Be very interesting to find out. Okay, thank you for watching my video. Thank you for watching again, and stay tuned for next videos by subscribing, and please show your support by liking this video, sharing it, and commenting for future videos. Thank you for watching. Have a good night.